everyone, so today I will be telling you about car safety, and this has to do with impulse or the change in momentum. Okay, so imagine that you are in a car crash. Both cars, crashed exactly at the same speed, so the crash has happened, and that's how the cars ended up with. So you have A and B, that's the appearance of the cars after the collision. Which car would you rather be? I am not going to give you the answer just right now. You will see as the lesson goes along, okay? But try to think about that formula, okay? Remember that impulse or change in momentum says that the change of momentum, so the final momentum minus the initial momentum in kilograms meters per second equals the force that acts on whichever body has this change of momentum times the acting time. Acting time in seconds, force in newtons, okay? Now, if you think about it, whenever you have a car collision or a car accident, your change of momentum is going to be your final momentum, 0 minus the initial momentum. So these questions to do with car safety are to do with change of momentum or impulse, and therefore, because you cannot change your change of momentum, because it's your initial momentum, is all to do with force and acting time. So remember, I have two things multiplying each other. That's kind of a hint to tell you on how you should think about the question that I just asked you. So see how you're feeling about this, and you can either, to try to answer that question, complete the table below and draw some conclusions on how impulse depends on force for the same acting time, or how impulse depends on the acting time for the same amount of force. You may decide to describe straight away how impulse depends on force and acting time and relate your answer to car safety, or you can try to use the impulse formula to justify your answer. So which car would you rather be, A or B, and explain your choice of car by to be in during a collision, okay? So pause the video if you don't want the answers just right now, and if you prefer to think about it. Otherwise, the answers are coming now. So the first one, completing the table. So impulse is force times acting time. So I have 6 here. And then 4 times 3, that's going to be 12. 3 times 2, I have 6 again. And 3 times 4, that's 12 again. So I have 2 times the same impulse. So for me to have the same impulse, I can either have a longer acting time and therefore a smaller force, or I can have a bigger force for a smaller acting time. And the same happens when I do the exercises with the 12 for the impulse. So the bigger the force, the smaller the acting time, or then the smaller the force, the bigger the acting time. So now maybe we are thinking that if I have a car accident and I can increase the time or the acting time, so the car of the time of the collision, the force on me is going to be smaller, because bigger the force, then smaller the acting time, or smaller the acting time, bigger the force acting on me for the same change of momentum. So because I know that, here we go, for the same acting time, the bigger the force, the bigger change in momentum, and for the same force, the bigger the acting time, the bigger change in momentum, then it means that I want to be in a car where the collision is going to take as long as possible. So car A would actually be the best car to be in, the car that looks all crumpled. But the reason why it is all crumpled is because as it was crumpling, it actually decreased or increased the time for you to stop and to get a change of momentum, which would be your total change of momentum. Because the time is longer, then force is going to be smaller. Remember that impulse equals force times acting time, okay? So, in summary, for you to have stuff for you to write notes, in a collision, a moving car is brought to stop. Therefore, the final momentum is 0. The size of the force exerted on the car and the passengers during the collision depends on the time the collision lasts. And you know that impulse equals force times acting time. So the longer the acting time, the smaller the force for the same change of momentum. So there it is. The bigger the force, the bigger the time, the smaller the force for the same change in momentum. This is actually an ideal 3-mark question, or an ideal 3-mark answer, okay? So in a car, you want to have safety features such as crumple zones, seat belts, collapsing steering wheel. What else do we have? Airbags. All of these things are made and designed to increase the time that you come to a stop. Therefore, using the impulse formula, decreasing the force on you on a car accident. So, crumple zones. Cars are fitted with front and rear crumpled zones, with a rigid box in the middle. They are designed to crumple gradually in a collision. They have predetermined positions, making the duration of the collision longer and therefore the force exerted on the car or the passenger smaller. And I'm gonna add this link here in the description about crumple zones, how they work, and how this makes you to be in a safer car if your car has crumple zones, okay? I will also add, I think this link doesn't work and therefore needs to be this one, this link about the fifth gear, where you have the Ford Focus on a 120 miles per hour car test. And let's think about it. If I have an accident at 120 miles per hour, then the time of the collision is going to be extremely small. So the time of the accident is extremely small because I am going at a very fast speed. So what is going to happen? The force on the passengers is enormous. So watch the video, and after the collision, so this is a car test, no one gets killed obviously, but it's quite haunting actually seeing how the car crashes. And then after the collision, they say the time of the impact, which I believe is in microseconds or milliseconds, and the forces that the passengers would have felt. So watch that video because it's going to really give you an idea on how the acting time makes a difference on the force acting on the passenger, okay? So, car safety, in summary, we have seat belts, airbags, crumple zones, collapsing steering wheel, which I didn't add here in the PowerPoint. And all of these things are there to increase the time of the crash, the time for you to come into a stop. And this decreases, therefore, the rate of change in momentum. And therefore, it decreases the force that is exerted on you, the driver and the passengers, okay? And this is because I, impulse, equals F force times T acting time. Alright, so that is it about car safety. Basically, car safety or any impulse formulas is all about you knowing that the longer the acting time, the smaller the force, and applying that to, again, either safety or any type of problems that appear. Car safety is a full lesson, so it could be that car safety is an exam, but even if it's not, knowing these ideas will definitely get you full marks in an exam, okay? So, hope it made sense. Up to my next video. Be happy and healthy. Bye!